Thermal equilibrium. Heat transfer is happening all around us. Take for example the cooling of hot coffee with an ice cubes. As the ice cubes came into contact with the hot coffee, the ice cubes start absorb the hot coffee thermal energy. This rises the ice cube's temperature and eventually cause the ice cube to melt. Meanwhile, the hot coffee loses the same amount of heat and subsequently making it much more cooler or having a lower temperature than its initial temperature. It's like the ice cube borrowed the coffee's heat to warm itself, but at the same time leaving the coffee feeling refreshed. To understand the concept of temperature, it is essential to grasp the two keywords here, which are thermal contact and thermal equilibrium. Thermal contacts refer to a specific physical conditions where the two objects are physically touching or close enough in such a way that energy exchange between these two objects become possible. Okay, so for example, cup of hot coffee that is placed on top of a table is in thermal contact with the table surface, and several types of contact can exist, which are direct contact and indirect contact. Direct contacts mean the two objects are physically in touch with each other at their surfaces, and this arrangement allows the most efficient energy transfer between these two objects, whereas the indirect contacts means the two objects is not directly in touch with each other, but they are still close enough for the energy transfer occur through radiation or convection. So the essence of thermal contacts lies in the potentials for a flow of thermal energy. So when two objects are in thermal contacts, heats flow from the hotter objects to the cooler objects. This exchange in energy will be continued until the temperature equalizes between these two objects, or what we call as reaching thermal equilibrium. There are three different processes of thermal energy transfer, which are radiation, convection, and conduction. When two objects are in thermal contact and reach a state where there is no net change of energy, both of these objects are said to be in thermal equilibrium. This means while energy, which is in the form of heat, might be still moving back and forth between these objects, the overall amount of energies stay constant in each object. In simple terms, both objects reach the same temperature. So if we refer back to our earlier example about the hot coffee and the ice cube, after certain points, the hot coffee and ice cube will eventually reach a stable temperatures, right? And this point, they are in thermal equilibrium and no further changes in temperature will occur as long as the condition remain unchanged. The zeroth law of thermodynamics says something pretty straightforward. Suppose you have three objects. Let's call each of these objects as A, B, and C. If, let's say, object A and object C are in thermal equilibrium, or in other words, they are in the same temperature, and the object B and object C are also in thermal equilibrium, therefore, we can conclude that the object A and object B are in thermal equilibrium with each other. So it is like an friendship triangle analogy. If A is friend with C and B is also friends with C, then A and B have to be friends too. This law is super important because this is how we can measure temperature. So we can use thermometer like our object C in our example here to measure temperatures. If the thermometer reach thermal equilibrium with whatever we are measuring, like an object A here, and because of the zeroth law, we know that if we took the same thermometer to measure the object B, therefore we can say that object A and object B are also in equilibrium with each other.